circuit right here. Here we have 30 voltage and the resistor R1 that is 2 ohm, and then resistor R2 that is 5 ohm, and then this one, let's call this one R3 that is 3 ohm, and we have a 10 voltage right here. Now let's try to find all the currents that are flowing through this circuit. Here we have I1 current flowing through this, and then let's call this one I2, and let's call the current passing through this one I3. Instead of I3, you can actually give a beta expression with two unknown variables using a KCl. Now let's see how we can do that. In KCl says that whatever the currents entering through the node is equal to exiting through the node, or you can say whatever the current going entering, exiting, if you add them all together, that should give you 0. So if I take this node right here, here I1 is entering. So let's put the equation first. KCl sum of I in is equivalent to sum of I out. So what are the currents that are entering this node? I1 is entering, so I put I1 right here, and then I2 is exiting, so I put I2 in the other side, and then we have I3 also exiting this node, so I put I3 also in this side. Now here you can see, like, what we can do is we can take the I3 separately and equate that one to I1 minus I2. If we do that, instead of this I3, I can replace this one with I1 minus I2. If I do that, the problem will be much simpler because we only have two unknown variables. So let's do that one right here. Instead of I3, I'm plugging I1 minus I2. Okay. Now we have done this. The next thing is what we can do is we can apply Kirchhoff's voltage law in the loop 1 and loop 2. Let's take the current direction in this one and this one for this one. Okay, if I apply Kirchhoff's voltage law KVL at loop 1, let's call this one loop 1, let's call this one loop 2. So if I apply KVL at loop 1, KVL says that if you add voltage around a loop, that's going to be equal to 0. So if you add all the voltages around this loop, that should be equal to 0 according to Kirchhoff's voltage law. And whenever we current passing through negative to positive, you have to know that voltage is positive, and if the current pass through positive to negative, then the voltage is going to be negative. And here the current flow this side, so we know that current pass from higher potential to lower potential. So this is going to be plus right here, and this is minus, and here also this is plus, this is minus, and for this one plus minus right here. You can assume opposite as well, like you can assume current passing in the opposite direction. It's gonna actually give the right answer, but you will get negative if the answer is opposite. So you can take any direction you want. So let's actually apply Kirchhoff's voltage law right here. So here the current is going from negative to positive. So that's the positive voltage, 30 voltage. And then the next one is we have I1 right here, and then resistor R1. And we know the resistor that is 2 ohm. And if I apply Ohm's law says that V is equal to I times R. And if I apply Ohm's law here, this is going to be, first this is negative because this is going from positive to negative. So the voltage is going to be negative. So I put a minus right here. And then according to Ohm's law, V is equal to I times R. We don't know the current. We know the current is I1 right here. So instead of current, we can put I1. And the resistance is 2. So this is going to be 2I1. And then here, again, the currents flow through this. This is I2 current flow through this. And then that's going from positive to negative. So we are going to have a negative voltage. So this is, and also we know the resistance right here, that's 5 ohm. So this is negative 5I2. That should be equal to 0. So we have applied Kirchhoff's voltage law in loop 1. Let's call this one equation 1. Now let's apply Kirchhoff's voltage law in loop 2. KVL at loop 2. Now we assume the current's direction this, and here you can see the current is flowing from minus to plus. So again, if the current flows from minus to plus, that's a positive voltage. So I'm going to put positive 10 voltage right here. And then here, this is again plus to minus. So if it's plus to minus, that's a negative voltage. So this is going to be minus, and then current passing through this one is I1 minus I2. So I put I1 minus I2, and also we know the resistance, that is 3 ohms. So 3 times I1 minus I2. And then the same, actually we know that the current passing through this resistor is I2, but if I am going this way, the voltage is going to be negative, and the current direction is opposite, right? So this is going to be negative right here, and then we are going to have 5 I2, and that is equal to 0. Okay, now we have two equations with two unknown variables. Now let's see whether we can simplify and eliminate one of the variable. So first one, we don't have anything to simplify, but for the second one, we have to expand and simplify this one. So let's try to do that. Let me use a different color. Okay. So this is 10, and then minus 3 times I1, that's minus 3 I1, and minus 3 times I2, minus 3 minus I2, that's plus I2, plus 3 I2. And then here we have minus 5 I2, and 3 minus 5, that's negative 2 I2. So we can say, okay, this is equal to 0. And then this is the 10 minus 3 I1, and then 3 minus 5, that's negative 2. So negative 2 I2, that's equal to 0. Okay, so now we have this equation, this equation. Okay, also let's remove this voltage to avoid the confusion, because this is voltage is just the unit. Okay, so 30 minus 2 I1 minus 5 I1, and here we have 10 minus 3 I1 minus 2 I1, 2 I2. So what we can do here is we can make this I1 equal, we can try to make this I1 equal and eliminate them. To do that, I'm going to remove this one here because we are lacking space. I'm going to remove this one. Okay, so let's bring the equation 1 here. Here what we can do is we can multiply this one with positive 3. If I do that, this is going to be 90 minus 6I1, and this is going to be 15 I2, that is equal to 0. Now let's bring this one here. If I bring this one here, and here to, we have to see if I multiply this with which value, when I add them together, that's going to give me, that's going to eliminate one of the variables. So here, if I multiply this one with negative 2, this will give me positive 6. So if I add them, that's going to give me one unknown variable. So what I'm going to do is I'm going to multiply this one by negative 2. So if I multiply this one by negative 2 and put it here, this is going to be negative 20, and then negative 2 times negative 3 I1, that's positive 6 I1, and then negative 2 times negative 2 I2, that is positive 4 I2. That's equal to 0. Now let's add them together. 90 minus 20, that is 70, and then 6 I1 cancels each other, so this is eliminated. And here we have negative 15 I2 plus 4 I2, that is negative 11 I2. Okay, that's equal to 0. Therefore 11 I2 is equal to 70. Therefore I2 is going to be equal to 70 divided by 11. 70 divided by 11. Let's calculate that. You know what? Let me double check everything if I did everything right first. So KVL at loop 1, 30 minus, oh, okay, and then KVL at loop 2, we have 10 minus 3i1 minus 5i2. Okay, let me see if the direction is right. Okay, positive 10, and then here we have minus 3, and then i1 minus i2. Okay, and then we have minus 5 i2. That's oh shit. Okay, you know what, here the currents flow into negative to positive, so this is a plus i2, plus 5i2. You can see this, we are already assigned the resistor plus minus here, but if you are taking from this, it's still minus plus here, so it's going from minus to plus, this plus 5i2. So that's a mistake here, I have to correct that. So this is plus 5i2, and so if I do that, then this is going to be plus 8i2, and if I multiply that one with negative 2, that's going to be minus 16i2. So this is minus 16i2, and minus 16i2 minus 15i2, that is minus 31i2, minus 31i2. So 70 minus 31i2 is equal to 0. Therefore 31i2 is equal to 70. So i2 is equal to 70 divided by 31. Therefore i2 is equivalent to 2.258 ampere. Okay, so now we found out i2 is equal to 2.258 ampere. The next thing we can do is we can plug this one in one of these equations where we have only i2 and i1 or something like that. Like we only have two unknown variables, i2 and i1. We already solved for i2, so we can actually find the i1 by plugging one of these equations. So let's choose the simplest one. Let's choose this one. Okay, I'm gonna erase the bottom part. Okay, let's go ahead and plug it. So this one is what? This is 30. Like let's rearrange this one in terms of i1. So this is going to be 30 minus 5i2 is equivalent to 2i1, and 30 minus 5 times I, instead of i2 I put 2.258 is equal to 2i1, and then and if you rearrange and solve for i1, you're going to get 9.9355 ampere. Okay, so that's basically i2 and i1. Okay, those are the two things we wanted to find, and we already found it. In case if you want to find i1 minus i2, you have to just subtract this i1 i2 from this i1 and find this. You can find the, let's call this one i3. Okay, if you say this is equal to i3, then i3 is equal to, if you calculate that one, you're gonna get 7.097 ampere. That's i3. That's equivalent to this. Okay, now we have found out the currents, and you can do additionally one more thing, that you can find the voltage across here. That is you can do that with delta V is equal to negative I times R by using the Ohm's law. Why it's negative? Because when the current flow from positive to negative, the voltage is going to be negative across the resistor, so that's why we have negative right here. And the delta V is going to be whatever, like if you call this one point B, and if you say this is point A, at point A we are going to have 30 voltage. At point B, if you want to calculate, you can delta V is VB minus VA. Whatever the voltage right here, minus this is equal to negative I times R. By doing that, you can calculate the voltage here, and the exact same voltage is going to be here as well, because we don't have any voltage drop or resistor or anything. So the voltage is going to be exactly same here, and the voltage here at this point is going to be additional, like with plus 10. Whatever the voltage, if you get, like whatever the voltage you're getting here, let's say you're getting voltage X, the same voltage is going to be here, and the voltage here is going to be X plus 10 because of this voltage source right here, the battery. Okay, that's all you have to know, and that's it for this video, guys. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.